So let me know when you've got that screen.
It's there.
All right.
Got it.
All right.
Let's
Fuzzy.
take a look at why flame resistant or FR clothing
Oh,
matters.
you got the wrong screen. We looking at your email.
Well, I don't want you to see my email.
I'm reading it.
Screen 2 again. Share.
Yes.
Just there.
All right. So let's get the first 8 seconds here.
Let's take a look at why flame resistant or FR clothing matters. If someone is accidentally exposed to a short duration, high temperature event like a flash fire or an electric arc flash, their non-FR clothing could easily ignite and burn. If this happens, the amount and severity of the burn injury could actually be more significant than what would have been caused by the event itself. The recovery time could be very long and painful, and the chances of survival drop dramatically. Here is a chart developed from data collected by the American Burn Association. The vertical bars show the survival rate percentages for different age groups based on the amount of burn injury. The blue bar represents a body burn injury area of 25%, and you can see that all age groups have a very high rate of survival. The purple bar represents a burn area of 50%, and although the survival rate has dropped, even the older individuals have close to a 50-50 chance of survival, while the younger group has up to an 80% chance. However, when we get to the yellow bar that represents a burn injury area of 75%, only the youngest people have a chance of survival above 50%, and the oldest group has only a 10% chance.
That's me.
Fortunately, flame-resistant clothing can help provide protection in the event of accidental arc flash or flash fire exposure by not igniting and continuing to burn. Plus, it can also provide a degree of additional escape time in the aftermath of a flash fire. To learn more about how FR clothing works, watch FR Clothing Basics Part 2.
That's one. Let's see. Arc, flash.
Monday.com work docs is a new kind of doc.
Let's see. This one's got a little bit lengthy now, but it does tell a really good story that is true. 14 minutes. I want you to pay close attention because I'll be pausing this here and we'll be discussing some of the things that went wrong and some of the things that the employee, good grief, that the employee did wrong.
This particular night, things were pretty normal.
That's just that a person didn't stay focused.
Everything was down and you could just feel a steel in the air. It was like you could just know something was wrong.
It's the worst thing I've ever seen in my life.
Useless. It shouldn't have happened.
I've got an image burned into my mind that'll probably be there forever.
Someone lost their life for nothing.
We lost a friend, and he's missed. Folks miss it.
On January 18th, 2001, Eddie Adams, OSB mill shift electrician in Elkin, North Carolina, lost his life as a result of burns received from the explosion of a 2300-volt starter. Eddie left behind his wife, 2 children, and countless friends. Eddie's friends and co-workers produced the following program in order to share their thoughts and to prevent a tragedy like this from ever happening again.
As we go through this door, we're entering the MCC Room number 1, which is the location of the starter can.
Well, anytime you go in the MCC room, you're supposed to have a partner. And anytime, you've got a job and you can't do it safely yourself, you have to ask for somebody to take, hey, come help me a little bit.
Okay, so what's a good practice here as far as when you start working on voltages? What should you have with you?
Or with a partner?
Yeah. Depending on your utility and your amount of experience, you're always going to have a partner with you. Now, I'm sure, and this is Professor Vermelin out there, he's got plenty of years and a lot of responsibility, and down there in Andrews being the only area service technician. Professor V, you worked alone a lot, right?
Yeah, most of my time was spent, by myself with stuff.
Right, but when the situation came and he was a good judge of his work environment and what he needed to do, if you needed help, what did you do?
For
a partner. Yeah, called for a partner. Yeah, you called for a partner and backup help.
That's one of the first mistakes Eddie made. He came in here, which is the same room, by himself. Nobody even knew where it was at.
I'm saying that nobody never goes in there by themselves, I'm sure they think, well, maybe I can fix this right here real quick. And I'll go check it out.
As we come through the MCC room, we have most of our 480 volt cans located in this area. As we get down further toward the end of the MCC room, all of our 2300 volt and high voltage type of starter cans are located down in this area.
They had an issue with the hog motor cutting out, and that's what Eddie was working on at the time of the fatality.
Hog grinds up our bark and waste material. A hog was down, and the hog had failed.
It wasn't a tremendous upset condition. It wasn't a life or death situation. It wasn't something that was so critical to the process that it had to be done right now.
This is the actual starter can that Eddie came to work on. As you can see, it's no longer in operation. When we were at the point that we were able to go ahead and start putting the equipment back online, this was damaged to the point that we couldn't use it any longer.
So the explosion and fire was so intense in that one panel, they call them cans, in that one panel right there, they couldn't even put it back in service, couldn't even repair it. So they just either installed another panel or switched over to another one.
When Eddie came in to...
You see this, what do you call that?
Steel plate?
Yeah, that steel plate that got over the top. Well, the explosion burned a hole through the metal right there. So they had to cover it with something.
Work on this piece of equipment. He had to have pulled the handle down on the starter to do a lockout. This particular piece of equipment, you can't open the door unless you disconnect the breaker.
There's no way that you can open that can without throwing the disconnect down. You can't do it. So he throwed it down. He did that part right. But once he got in there, he throwed the breaker back up.
Okay, so problem number 2. So he takes the breaker handle and he pulls it down to be able to open the door. Then what does he do?
Starts it back up.
Yeah, he fires it back up, which is really easy to do. You're just reclosing the switch back. So you're bypassing a safety lockout device. So that's problem 2.
So then it was live.
When he did that, he used a multimeter and was using a multimeter.
Can anybody read the voltage right here in the yellow?
2300.
2300 volts. When you guys start using multimeters or voltmeters, they will have a range. Right? And typically the ones that we have were Fluke type. That's the name brand of them, went up to 1000 volts. What is the voltage we have here? 2300. So we'll get to it right here. The wrong piece of equipment to use.
And we feel like that maybe he was trying to check the fuses to see if he had a blown fuse.
He thought he was on 600 volt, had a 600 volt meter, put it across phases of a 2300 volt system.
Okay, so that won't work. 600 volt meter, trying to test 2300 volts. So something's going to go.
Even though it was marked all over it, and there were all kinds of indicators using a 2300 volt panel, he didn't recognize it.
You can't check 2300 volts with a 1000 volt meter.
As he attempted to do that, whatever he did inside this box created an arc with an explosion. And As the explosion, or as the starter exploded, of course, a ball of fire came out into Eddie's face. We found Eddie's hard hat here on the floor, along with his multimeter that had blown up.
Yeah, that's destroyed.
Yeah.
Okay, that's the front cover, that's the protective cover, and there's the meter sitting over there on the floor.
It had melted. We know that from the impact that Eddie was slammed into this cabinet here.
So the force of the explosion, when it came out, dented this cabinet behind him. It threw him into the back cabinet.
We also found evidence of some tissue and some hair on this panel itself. When the explosion took place, every light in the mill went off, so we feel like it was probably dark in here for a few seconds, and Eddie was on fire.
The dryers started on fire. They got fire suppression signals that the suppression system was activated. No one knew what had happened. Most people assumed there'd been a power outage. Well, there had been. But immediately, no one understood that power outage is because the circuit was shorted through Eddie Adams.
Eddie turned at that point and went in this direction. There was a small table-type device sitting here, and it appears as though Eddie either slipped or bumped into the table. We found his watch. We found some coins and some bits of clothing laying on the floor here. So it appears as though Eddie might have slipped and stumbled into this table. He got up and went in this direction, starting towards this door. And we feel like that Eddie realized that he was not going to be able to get out this door. So he turned and started back in this direction. There was a roll-around toolbox sitting here with some plastic covers over the top. And as Eddie went by, he swiped that top, and it actually melted the covers there.
So the guy is literally on fire.
He also started on through here, and again, we found bits and pieces of clothing throughout this area. He opened this door and went out into the blending area.
It's pretty obvious to tell what he did. He took his meter, probably laid it on the floor down. He had to squat down more likely, and you can see from the heat right here where the fireball started. He put his meter on there just like that. As soon as he did it, that was it. It blowed. The fireball blowed right there between them. And you can see the heat where it's melted the fuse. It's actually welded the fuses. Here is welded the stabs together. All the fireball was right here in front of his face. And when it blowed up, and the energy from that fireball caught him on fire. And the rest is pretty much history.
This guy was burnt plumb out of his clothes. I mean, there was a t-shirt band, the waistband and his belt was all that was on him. I mean, that was all that was on him.
He took it upon himself to go in and try and do the last steps of troubleshooting before making a decision to change the motor. And for whatever reason, what he was working on was not foremost in his mind at that time. And what he was doing was not communicated to others, and others didn't ask questions of Eddie.
I think in this case we had somebody who was really anxious to help. As the pastor said at the service, Eddie would drop anything to help you. If you needed some help, he would drop whatever he's doing and come over and help you. He'd do that at home, he'd do that in the community, he'd do that all the time. And I think that behavior of I'll run and fix it, I'll take care of it, because I know what to do, I'll run in there and I'll fix it, is a behavior that we have to watch.
As he came through the door, it appears as though he slipped again. We also found some fluids, body fluids, some skin, and again, pieces and parts of his clothing. He proceeded to go up next to the form line and down the form line. And of course, as he was going down the form line, it was still dark. And in different spots along the form line here, we found bits and pieces of his clothing.
You know, some of them told me that they had seen him from, from across the mill, and seen something that was on fire, and thought, well, what is that on fire? And then go to look at it, and see that it is somebody.
After they put the fire out on Eddie's body, they brought him into the first aid room here where they started to administer first aid. Of course, at this time also, the control room operator was on the phone with the emergency response organizations in the area.
Every time the phone rings now after 9 o'clock in the evening, the fear of God runs right through me, because it could be the same phone call again. And boy, that's a phone call that nobody ever wants to get.
Jeff and I drove over to Kathy's house. We had to call Kathy from the driveway, inform her that we needed to talk to her.
Eddie was conscious and he was still focused and was able to talk with our first responders and with the EMTs.
And really, until we got to Winston and talked to the doctors down there and kind of seen how the trauma team acted when we got to him, or when they got to him, I knew then that, you know, this is pretty grim.
As he talked with the EMTs that transported him to Winston-Salem, he also told them that he thought he was on 440 or 480 and that he had really screwed up big time.
Carelessness, really. It was something that you just don't rush into. Anytime you're dealing with electricity, you just don't rush into it.
You almost have to try to get hurt. You have to do something that violates the policy, something that violates common sense. You know, you have to do something totally off the wall to get hurt.
Again, Eddie was alert and was able to talk with the EMTs as they were transporting him to the hospital. And the next day, Eddie died.
Eve to me is basically freedom. It's a giant open universe where
Elkins said, no, don't come. We don't want anything to do with the film. Leave us alone, let us be. Don't invade us. And when they thought about it and they realized that there might be a little window to help the rest of the company and the people we care about from going through this, they said, okay, I'll take some more pain.
If by doing the video, if we can prevent 1 mill or 1 person from having a tragic event similar to this one, then it's been worthwhile.
But I thought maybe if I can just say anything to help somebody in safety, just think twice about something before you do it.
Am I ready to be focused? Am I ready to go in and do my job and do it safely so I can go home at the end of the day and get in as good a shape as I was when I got there?
Someone lost their life for nothing. That they lost their life for nothing. And I don't want that to happen again. Not to anybody. Not at my facility or anybody else's facility.
Okay, so, I mean, there's a couple comments in there that are pretty strong. You first know what you're doing, know what you're working around. And he said, that one guy towards the end there said, well, you got to know the procedures and have what else?
Common sense.
Common sense, gentlemen, common sense. And common sense is going to help you 90% of the time, knowing the procedures the other 10. And as I've said it before in safety meetings, if you question yourself and say this is safe, it's already unsafe if you're having to question yourself about it. So plenty of safety procedures not followed. Did anybody say anything about rubber gloves?
No, sir.
Didn't hear a word about it. You got to use rubber gloves in the utility industry on any voltage that you work. Anytime that you're around voltage, rubber gloves must be worn. How about FR uniforms?
He didn't have one.
He didn't have one. And to be honest with you, the guy that's walking through the plant here,
Didn't have one either.
He doesn't have one either. I don't know what their policy is, but as soon as you get into an area that has electricity in it, that requires FR uniforms, you should have an FR uniform on. Now, he did give some gruesome details. The clothes were burnt right off him, and we found some body fluids. Well, can anybody guess what those body fluids were?
Piss and poo.
Fat fatty tissue burning off. Okay, so big deal here. One, if an FR uniform is required, and we'll talk about this in just a moment, to do your work, then wear your FR uniform. Now, I'm going to throw a question out there. I've said it specifically. Do you need to wear an FR uniform when you're working in the proximity of or on electric lines?
Yes.
Does that mean you have to wear an FR uniform all the time?
No.
No, you don't. Some utilities, if you're out in the middle of the woods and you're building a brand new line, setting poles, pulling wire, setting transformers underground, and putting underground wire in, and there's no voltage present, an FR uniform is not required unless your company specified it. Professor V?
Yep. And that was a thing that actually came down to the wire for us a few years ago. Was we were actually wearing just like a regular t-shirt during the day because of the heat. And then when we got to the job, we pull our FR shirts out and put them on. But management decided that, that was not all right. And Duke has a policy of when you step out your vehicle onto the to your work location where you report to, you're fully clothed in FR, not t-shirts. It's full FR, long sleeve shirts. Don't care if it's 110 degrees outside, you're going to wear that FR clothing all day long.
Yeah.
So that's the Duke Energy policy.
Yep. Okay. So there you go. There goes a different policy for that organization. Follow your organization's rules. Now, Professor V says something. Guys, FR uniforms are hot. There's just no way around it. Okay. Long sleeve FR. These are actually FR jeans. They have FR jeans and FR khakis also. But you're going to be working in situations where it's 90+ degrees and it's going to be hot.
Yeah.
Still have to wear the uniform. Now, what do you wear under it?
T-shirt.
I heard a t-shirt. Who was the other?
Just regular clothing.
It's good practice too, because even the intensity of the heat, will penetrate. It won't ignite. It won't turn this into flame. But the intensity of the heat, 100% cotton, gentlemen. All right, wear 100% cotton t-shirts, 100% cotton underwear and socks. There is fire retardant qualities to 100% cotton. So make sure you've got that on too. All right. How about the nose rings and the earrings and the watches and the wire rim glasses?
That's a conductor.
It's right. Well, it's a conductor of electricity and heat. And heat. Once that flash occurs, all of those items will get extremely hot. I've seen watches burned into arms, wire rim glasses burned into the sides of foreheads. You have to take off all the metal that's on your body. I saw a bunch of linemen that went to from a metal belt buckle to one of those clip plastic type belt buckles. You got to get all the metal you can off your body. Okay. Any questions? Well, Professor V, I've got one. Where do I get my uniform from?
Ooh.
The company you work with?
Right. All right, the company is responsible. So they will get you uniforms. They're depending on your company, you have different plans. Usually you get 2 weeks worth of uniforms and they do the laundry service for you. They supply the uniforms.
Yeah. Now at Duke, the part of Duke I was involved with, they bought you to start with when you go to work with the company, they bought you 7 sets of uniforms. And then of course you had to pay for any laundry service or whatever, or you could do them at home or whatever. They didn't offer any assistance with that, but we had an allowance for uniforms every year. It was like $500, which that does not go very far with FR because it's so expensive. So you had to take really good care of your clothes. I mean, and they didn't mind you spending your own money if you wanted to go buy something else, but really it was just too much. The pants themselves were, you know, $60+ for a pair of pants. The shirts were pushing the same thing or higher, depending on what grade of FR clothing you got. And Professor Shoemaker talked about the 100% cotton t-shirts you wear up underneath. Well, the company that Duke went with that supplied us our uniforms actually had what they call base layers FR. It was really thin FR, and that's what you could wear up underneath. But I mean, you were just stacking on more layers of FR, and it just really just got hotter and hotter. So, but I mean, it's there for your protection, just like your safety glasses and rubber gloves and hard hat and those kinds of things.
Right. Speaking of which, what about around your neck area or your face? I mean, can you put FR over your face, everything?
Yes.
You can. They do make FR masks. Those are hot too. They make FR bandanas. The safety vest, while you're directing traffic, the company's going to issue an FR safety vest. You're going to get a company issued rain suit. That's FR. So the importance of FR is pretty darn big.
Yeah. And you know, they talked about we talked about it. You talked about the guy going in there that was doing the video and he didn't have on FR. Well, I had to go pretty regularly to a plant over in King Street to work, a very large plant. And I had to go assist them one day, kill some power to one of their breaker rooms over there. And they didn't wear the FR uniforms, but they had arc flash suits they had to put on from head to toe. And I mean, it was middle of July. I mean, it was hot outside and they were inside with no power on. And this thing I'm talking about, it looked almost like a spacesuit. It was so big and cumbersome, but they would not enter that room and work on any of those breakers without that suit on.
Right.
I mean, it was kind of tough to work in, but they were following procedure and protocol and safety measures to make sure that, just in case something did happen in there, that, they wouldn't get hurt. So, I mean, it's a good thing.
Okay. Any other questions there? Any other concerns, thoughts?
A statement, know your equipment you're working with. If he had the right equipment, he probably would still be breathing today.
That's true. I mean, he used the wrong piece of equipment on the wrong voltage right there. And another factor that's in there that we really breezed by really quick. What time of the day was it?
It was nighttime.
End of the shift. And this, I mean, they've done studies on this, especially at utilities. In the morning, when do most accidents happen?
At the end of the shift.
At the end of the day, yeah. At the end of the day, you're working long hours, you become complacent.
Do you think maybe he'd done that before?
Oh, yeah. I mean, done that job?
Yeah, just kind of slipped in there and did that and slipped back out. And...
Yep. Complacency.
Yeah, that'll bite you every time.
Not
every time.
All right, well, let's talk about the homework yesterday. And you guys that are getting the homework done, you notice when you text me, I give you kind of hints and whatnot. Appreciate you getting that homework done. Those will get you some points later on. Those who are not doing homework, well, you don't get points. I'm going to share a screen here. So the transformers, did you get screen 1 or screen 2?
Yeah, transformer.
Okay, cool. So the transformers we were talking about yesterday, we had a high voltage coming in and a low voltage coming out. You had 3 choices there. You had step up, step down, or auto transformer. And I was hoping you'd do a little bit of an investigation. Some of you did. If I take a high voltage, convert it, and I get a low voltage out, I'm stepping down. That's a step down transformer, high to low. I'll give you the other two. If I'm at a generating station, you see these three pipes right here in the backside. If I've got a low voltage and I want to raise it to a high voltage, I use a step up transformer. Now, step ups are mostly at generating stations. Taking a low voltage off the generator, put it in the transformer, and I'm stepping it up. Similar to the way that Professor V yesterday said I could hook a generator up to a regular transformer, step it up, but that's inherently dangerous. This is a step up transformer to generating station. What was the third one we talked about, or I gave you an option for?
An auto transformer.
A lot, and I'm not gonna, if you put auto, we got it right. Why did some people say auto?
Because both of them are called auto transformers?
No, these, when you say auto, Logan, auto means I get to change voltages automatically. When a transformer comes from the factory, it is preset to 2 voltages only, an input voltage and an output voltage. So if we have this transformer, it's rated just by the nameplate at an input of 7,200 and an output of 12240. So it's a fixed voltage. Auto transformers, on the other hand, can change the voltage on their own. That's why they call them auto transformers. Okay, anybody else put auto there, and what was your reasoning behind it? Well, I know about 10 other people that put auto, but they're just not going to speak up. An auto transformer, like we have in this photograph right here, does exactly what I said. You've got an input voltage, you get an output voltage. One of these bushings is grounded right here. And when I need to regulate or change the voltage, you see these dial hands on the front right here. I can raise and lower the voltage automatically on my own. If my primary voltage gets too low, this will automatically raise it. If my primary voltage gets too high, this will automatically lower it. So this is an auto transformer. Another name used in the industry is voltage regulator. Okay, any questions there? All right. Professor V, did you want to go over quiz, or do you want to take a break? It's about 8:40.
Let's take a quick break, and then, because it might take a little time to run through that quiz. If you're good with that.
Yeah, to review yesterday's?
Yes, sir.
Okay, we'll do. Guys, let's see, it's 8:41. Let's give you 14 minutes, 8:55. 8:55, let's be back.
Cool.
You're gonna come down to these 3 dots right below right here. Open transcript. Everything that was said in the meeting is in the transcript. Okay? So I don't quite understand what he's talking about when he said ratios. So you're going to go up to these 3 dots, or whatever you're using, whatever browser you're using, get the settings menu and click find. Ratio. I said it 58 times. Well, I just want to go to the first one. What I'm trying to do is help you cut down on your time right here. So here's the regular video, just start from the beginning. Well, ratio, R-A-T-I-O. This is when he starts talking about it. Bam. Takes you 24 minutes and 20 seconds into the video, and you can play it from there.
Basic principles of ratios. Guys, there's
if you want to cut down your time and you're thinking to yourself, man, do I have to watch that whole video over again? You don't. You have notes automatically made for you. Okay, any questions there? All right. Professor V, anything else you'd like to add before we get into what we need to work on tomorrow or for our
No,
quiz?
sir. I kind of said what I needed to say, so.
Me too. Me too. We'll keep reinforcing it. Let me put it the other direction. You guys that are keeping up with your work, that are texting me back, and I know some of you got this reply. I put an auto reply up last night. I got tired after 9 o'clock and wanted to watch a movie. I want to watch a movie with my wife. Guys, I'm not going to go past 9 o'clock on Remind. And I did have one at 11:20. It's just going to auto reply that I'm not there. So let's get our work done on time. You guys that are keeping up with the work, that are getting those hundreds, thank you, thank you, thank you for the dedicated work that you're doing here. All right, let's take a break. It's 9:28. Let's say 9:40. 9:40.
You got you.
Okay. So you download the Pulse app. I guess you would sign in with your normal college credentials, right?
Yes, sir. You sign in with your D2L, whatever all that stuff is.
All right. Would you mind hitting ELW110 and showing us? Because I know you got good grades. Oh, so you're going to go content. Then you go grades. There you go. There you go. Huh. Okay. Well, that's pretty cool. That's the first time I've heard about it.
Me too. And that's the Pulse app?
Yes, sir. On the App Store, it's called Bright Space
Pulse. Bright Space
Pulse.
Bright Space Pulse. I'm gonna have to download that and see.
Right. So I'm looking on. It's good for Android. It's good for Apple, and it's good for PC too. So great resource there. That seems to go a lot easier. There is a way that you can do it in normal D2L, but it requires some navigation. If you're able to bring up your courses, you can unshare if you'd like.
All right.
Stop share. If you're able to do it like that and that quick, man, that's sweet. Okay. So Bright Space Pulse. Thank you very much, Tristan.
Yes, sir.
Hurricane Sandy was approaching New York, and you guys need to take on the same attitude as a lot of our guys in Santee Cooper did. My manager called me and the vice president, and we got in a meeting of the 4 area operations supervisors. So we had 4 different areas: North Myrtle Beach, Garden City, and Conway. And we sat down in a meeting, and they said, we're going to need to get some crews together, approximately 25 people and the fleets, and go to New York. So, of course, we were sitting there. We all said, well, I can get this resource and this resource, all this kind of stuff done, and the meeting ended. Well, when the meeting ended, I went up to my manager and I said, can I go? And his answer was, well, Scott, I don't see any problem with it right now, but you're going to have to go under some sort of title, you know, because you're working up there, and you're going to have to really, crew supervisors can run crews. And the intention was, you don't really need an area operations supervisor because you got crew supervisors, the crews up there. I said, okay, well, whatever you decide. Well, I left. He called me right back and said, look, I want you to go up there, and you're going to be our operations supervisor there and our safety director. I said, great, fantastic. Now, I'm a salaried employee. And he did explain right off the bat, look, you're only going to be able to make 40 hours a week. You're going to be making your normal salary. You won't be able to make overtime. I said, no problem. Still wanted to be with the crews. So worked that first week, 16-hour days. And I have to admit, some of them turned into 18, 20-hour days. I kept track of my regular time and overtime. Of course, helped the crews out, deliver material, safety director, just did all my normal stuff that I did here in Myrtle Beach, but just up for a storm situation. We were up there for 2 weeks. We lived 1 week in a tractor trailer rig that held 30 people. That was kind of nasty. But that next week, we did get a hotel room in the Hilton in outside of Allentown, Pennsylvania. So we had to drive every day from Pennsylvania to New York to get to our work. All said and done, we return. I enter my time in my timesheet. I'm getting normal pay. About a week later, the manager calls me up and says, Scott. I said, yes, sir. And he says, look, FEMA's picking up the bill, Federal Energy Federal Emergency Management. And he said, I'm going to be able to pay you your overtime. I said, well, fantastic. Let me get a notepad started out here. And I said, fantastic. So I appreciate that. I entered all my overtime in, and about a day later, he called me back and he said, Scott, I said, what's that? I'm going to share the screen over here. Screen 2, share. I should just see a notepad up there.
Yep.
So your title was, when you went to New York, is you were safety director for all our crews. And they based the pay off of a safety director for Ohio Power and Light. That's the company that had the system up there. So let's take a guess of how much a safety director for Ohio Power and Light was making per hour. Any ideas?
$45 an hour.
72.
Anybody else? Safety.
100.
Safety
80.
Safety director. Okay, it was $136 an hour.
Good.
So let's do a little math here. We're in math. Let's take 136 and multiply it by 8. That's 8 hours a day.
1088.
All right, equals 1088. Okay. I was up there for 14 days. Equals
15,232.
15,300 and what?
232.
Thank you. 232. Okay. So that takes care of all my regular hours. 8 hours a day, 14 days. Okay. So let's take all the hours right here. So you get 136. Let's do time and a half of 136. What's half of 136?
68.
Let's add that together.
It's 204.
204. Okay. So that's my overtime hours. So I don't 100% remember of how many overtime hours I have, but the minimum would be 16. So that's another 8 hours a day. So we're going to go 204 times, what's the time symbol? 204, oops, sorry about that, times the other 8 hours equals what?
1,632.
1632 for 14 days times 14
is 22,848.
848. So I've got my regular time in, got my overtime in. This is 2 weeks now. Let's add those two together. 15232 plus 22848.
It's 38,171.
And you made that in weeks.
Not too bad for 2 weeks, huh?
Not.
All right. The moral of the story here is I went up there, and what were my expectations as far as money? My regular pay at my rate for Santee Cooper. What happened?
FEMA covered the overtime.
There you go, buddy. I mean, you get the opportunity to volunteer for work. I'm not going to say 100% of the time you're going to get a ton of money. All right. I will say, though, the opportunity and the possibility is very high. 1 and 2 is I liked it. It was very good. But you know what I liked more?
Helping.
Being with my crew members and restoring power.
Now I got a question. Do you have to be with your company for a certain amount of time before they send you out of town?
Nope.
So they can send you out the first year?
They can send you out the first day.
Yes, sir.
Yeah.
I don't know if you had that kind of experience or something like that.
Well, a lot of times, you know, with our situation with Duke, we had a bunch of young guys coming in. And if they didn't have their CDL, they might go drive the supervisor around or go drive an engineer around and be, you know, be used in that capacity.
Yeah. So, I mean, essentially what I did and what the other 4 one, I volunteered. Okay. And that's typically what you're going to do in an organization. Your supervisor is going to come to you, hey, we need volunteers for people to go to New York. Well, you can see my attitude. I'm out of here. I'm going. Okay. When we asked that question, 25 people chimed in real quick. Yep. And we're going to go. That's what a company is looking for. And I have to admit, was it hard? Heck yeah. Was it nasty? Man, you should have smelled that trailer. The food was excellent, but man, I will not forget that experience ever. And I learned a lot. I mean, I'm 25 years in the company. I never stopped learning. I learned a lot about different situations up there in New York. You get that opportunity to go somewhere, call Buggy. Now, how happy was my wife?
Happy. Well,
Not
Does
happy, happy when she saw that paycheck.
back, he was telling you to go
Happy for about 2 weeks. Then she saw that direct deposit. Honey, I love you.
when he going back out of town again.
All right, Professor V, thanks for the story time there and give me that little bit.
Yeah. And guys, I mean, we're going to tell you, you might get tired of hearing it, but we're going to tell you about our experiences on the road and stuff like that. But it's just, it makes it worthwhile, guys. So I want you guys to make the most of it and live this life for yourself. It's very rewarding. All right. Okay. Are you going to bring up a whiteboard again for this?
Absolutely.
And I say that the numbers in these questions have been changed to protect the innocent.
Hold on 1 second. Let me get my. There you go. Clear all drawings. Find my writing utensil. Oh my goodness. I do it all the time, Robbie.
Yes, all right.
Why?
Missing your pen, you might have to go in my office and get mine.
Yeah, I found it right on my mask.
Okay.
All right, ready to roll.
All right, guys. This is going to be another 10-question quiz. And I might just mix this up a little bit here. So, all right, let's start out with this. A transformer primary voltage is 13,200. Secondary voltage is 480. What's the ratio? Anybody?
So when you give your answer there, tell us how you did it.
So 1/27.5.
Okay.
So I took 13,200 volts and divided it by 488 or 480 volts.
Right. Okay. So remember in the drawing portion, you put 1 on the top, 2, and please give me that again.
27.5.
Thank you.
Okay. All right. Any questions with that, guys? And the reason why we're doing this so much is because we want you to understand it. And we're not going to know if you don't understand it well enough if you don't ask questions, but the quiz will be a dead giveaway if you don't do well on the quiz.
Remember, not only in the climbing part do we have tasks on our sheet to prepare you for an entry quiz or an entry pre-screening. This is the written part. They're going to give you a handwritten test. They're going to tell you, you got a transformer. Primary voltage is 7,200. Secondary voltage is 240. What's the ratio? That's why we want you to get into the company. Go ahead.
All right. Next question. All right. Transformer primary voltage is 7,200. Voltage is 240. How many amps will be on the secondary side if there are 3 amps on the primary side? And whoever wants to answer this, give me the steps and how you get this answer, please.
How you did it.
All right, so you take 7,200 and divide it by 240 to get your ratio of 1/30. You've got 3 amps as your primary. You'll take 3 amps and times it by 30, and you will get 90.
Okay. Awesome.
Excellent.
At any point, if somebody does not understand this, hit us up with a reminder, just ask it straight out.
Yeah.
Okay. Moving on. A service has a voltage of 240 volts. The current is at 72 amps. What size transformer is needed for this service? What are we looking for, first of all?
The wattage.
Okay.
Right.
So we're going to refer back to the pie chart. So we're looking for P. So what do we need to define this answer?
240 times 72, which brings out 17,280 watts.
P equals 240. I'm catching up to you. Times 72. And your P equals how many watts?
17,280.
Okay.
So if we go to our transformer chart.
Remember that's in D2L.
Yep, and we're looking, and I've got mine pulled up. I got it in front of me here, and it goes 5 kVA, 10 kVA, 15 kVA, 25 kVA. What size transformer are we looking for that?
About a 15.
A 15?
Why would you choose 15?
Because we got 17, you can overload it 150.
Okay. Straight to the point.
Straight to it. Okay.
Yeah. Good
Awesome.
answer.
Okay. Does everybody get that?
Yeah.
That was an excellent answer.
Sure was. To the point too. Don't forget to take that 17,280. We're still in watts there and convert it to kVA. 10, 100, 1,000. So now I'm 17.280 kVA. Excellent.
Okay. All right. No hearing, no questions. Okay. All right. We've got primary voltage is 7,200. The transformer is a 25 kVA. What fuse size will this transformer need?
So now, and I saw a lot of stumbles on this. Remember, a fuse is rated in amps. So I'm looking for I.
Yep. He
has supplied a voltage, and we needed to convert 25 kVA to watts. So let's go ahead and do that conversion right now. What's 25 kVA in watts?
25,000.
Correct. All right. I don't have my Ohm's law chart up. Does anybody?
Yeah, see there?
I'm pretty sure it's I divided by P over E. Hold on, I'll bring one up.
Yeah, it's I divided by E equals R or whatever or something.
We don't,
I equals
we
P
don't have our
divided by E.
here. We got a voltage, either a V or an E, and we've got a wattage, a P. So I's got to match those two. I equals what? All right, I'll go back. Here, hold on 1 second. We're gonna have to have this up anyway. Stand by. Ohm's law chart. Bang. And open image in new tab. Bingo. Shrink this.
P divided by E.
All right.
Yeah. P divided by 5.
It's the reverse of figuring out what the other one is.
Yeah, it's always good to either download an image or something like this and just have this on your device and ready. So in the question we provided P and E, so that's the one I'm going to use. Right? There's no resistance in the information we gave you, so these two are out of the question. This one, I equals P divided by E. All right, so let's run the math. I equals P, which is 25,000, divided by E, which is 7,200. What do we got there?
3.47.
3.47. All right. So let's run back here, and we're going to bring up our chart again, which is in D2L. Yeah. Up. Common transformer sizes, common fuse sizes, and amps.
You need a 5.
A 5.
Yeah, I would run the 5 also.
Yep.
Okay. 5 amps. Excellent. Bam. Clear drawings. There you go.
Cool. Questions? We got plenty of time if you got questions.
So on that question, don't forget, you got to use 2 outside resources.
Yep.
Ohm's law chart.
Fuse chart.
And the fuse chart in D2L. Okay.
Okay. All right. Hearing no questions. Did I have a question?
My phone kept cutting in and out, but
Go ahead.
what was it? So is it always watts over volts to find the amps?
Yeah, let me throw this.
Yeah.
Hold on 1 second. Go by the chart. Okay.
Okay.
All right. So it is just like, when we were figuring the amps before on a ratio, we have to provide some numbers to you for you able to get it right. So watch out what's provided to you. On that last question, in the question, we provided P. We actually provided KVA. Yeah, you had to change that to watts, which is 25,000. And in the question, we provided E, volts. And we wanted to find out what I was, okay? You gotta watch the question, then make it fit the chart. Okay, good question. Okay.
That's great. Use that chart.
Use your chart.
Yeah.
All right. Appreciate the question.
Yes, sir.
Are you going back to the?
Yep. That was an error on my part.
There it is. All right. All right. Hearing no further questions, we'll continue on. All right. It says primary voltage is 7,200. Secondary voltage is 120. Primary amps are 5. How many amps are there on the secondary side?
Well, we're not going to change our normal processes right here.
That's 300.
We're not going to change our processes here. Let's divide 72 by 20. Let's get our ratio.
1/60.
All right, what's the next thing we need to do in our process?
60 times 5.
60 times 5, right? Equals
300.
300. Excellent.
Guys are killing it.
I know it. I got it.
Nathan's back. All right. All right, let's catch this one, guys. If there's no other questions about that.
Okay.
Everybody's got that right. Okay. How much in kVA will a 37.5 transformer do in short-term overload?
So what's the maximum overload it can do?
100. You say it again.
Repeat the question.
How much in kVA will a 37.5 or 37.5 kVA transformer do in short-term overload?
So what's short-term overload maximum?
150%.
Okay. You guys work on it yourselves and be quiet a little bit. I'm just going to write. This is me writing. You might do it in a different fashion. 37.5 times 1.5. I converted my that to that. I'm going to grab my trusty calculator. All right, and C calculator, 37.5 times 1.5 equals, see if everybody got the same thing.
56 point, oh, sorry.
You're good, you're good, go ahead.
56.25.
Excellent.
That's what I got.
Okay, cool.
Okay.
All right, good deal.
Right, and just like we said, now I'm changing a lot of these numbers. The questions are basically the same. I'm just changing the numbers from what's on the quiz. Okay. All right. Now you got to think about this one a little bit. Okay. Let's say I got a 50 kVA transformer with an impedance of 2.5%. What is the true kVA of this transformer?
Okay, so I'm listening to that question closely. He wants the answer in kVA. Listening close. All right. So what action, I'll take from anybody here. What action are you going to take first?
Write out the 50,000 kVA.
Yeah, write out just the 50,000. It's not kVA anymore. Now we're in watts.
Yes, I meant just watts.
Yes, no problem. All right. Impedance means I need to take away from it. So I'm going to work on it. Well, Professor V.
Yes.
This is what Professor V does in his calculator. 50,000 minus 2.5 and then the percent key. This is what I do. 50,000 times 0.025. And I know, you know what I'm going to do? I know you're all using calculators out there. Punch that in your calculator. 50,000 minus 2.5%.
It'd be 48,750.
All right. What did he want his answer in?
So it'd be 48.7.
Exactly.
kVA.
Right, exactly. 10, 100, 1,000, 48.750.
kVA.
kVA, thank you. kVA. I forget too sometimes.
Yeah.
All right, clear all drawings.
Okay. Questions? I know that might have to make you think a little bit and how to use your calculator, but pop them questions in if you need them. All right, hearing none. Let's see, we have a secondary voltage of 240. The amps are 200. What size transformer is needed?
Oh, So the previous question, you did it by primary voltage. Now you're doing it by secondary voltage.
Right.
So we're back to the same thing again. I equals P. No, we're looking for P.
Yeah, we're looking for P.
We're looking for the transformer side. P equals E volts times I amps.
Right.
240 times 200.
48,000.
48 kVA.
Uh-oh, ooh, somebody said it wrong.
It'd be 48,000 watts.
Right.
Oh, yeah.
Don't forget.
He is watts.
Is there such thing in my chart as a 48 kVA?
No,
sir.
Okay.
So what we're going to use?
50,000.
50 kVA. Excellent.
Okay.
All right.
All right. 2 more. All right. Let's see. Okay, here we go. What is, let me tell you, what is the fuse amp value, let's say, for a 50 amp fuse in overload?
So fuses are transformers, are inherent. They have the same qualities as far as overload. So what's my percentage? Uh-oh.
150.
150%. Yeah. If a transformer will do 150%, then I need to have a fuse that'll do 150%. So I'm going to go 50. Converted my 150% to decimal equals
75.
Thank you very much. 75 what? Watts, volts, amps, resistance?
Amps.
Amps, that's right. Good deal. Okay.
Questions about overload, questions about amps.
Got one more?
Got one more. All
Okay.
right, guys. This one here, you got to think it out a little bit. All right, a residential customer has his thermostat set to 68 degrees year round. Winter temps average, let me see when I got winter temps at. Winter temps average about 72, I'm sorry, 32. My summer temps average 83. Are the summer temps harder on the electrical system than the winter?
All right, so I'm going to take
No, winter's harder on the thing.
How do you know?
68 from 32, and I get what? 36. 68, 83 from 68.
12
15.
or 15.
Right. Okay. Wow. Winter's more than double.
Okay.
Winter time.
Yep. Guys, see how we got that? A little bit of math.
Yes.
All right. So that takes care of the quiz. Any questions? Any concerns? Any I haven't seen anything on Remind. So
What time we have just like the Zoom thing posted today?
were you already in Zoom?
I mean, like
When's
the
video
whole
gonna be up?
lecture, like when the video will be up.
So just with everybody in the room, as soon as you guys leave the room, I convert here and then I send it up. Usually that takes about 30, 45 minutes.
Okay.
Okay. It takes about another hour for it to transcript. The transcript happens on the YouTube servers. Even with that, if you want to come back to us and we're not at lunch, we're here in the room to help you out. So
Gotcha.
guess what? There'll be a homework assignment today. One question. I'll go ahead and send it. I'll send it on a remind. You can go back and remind, but I want to do something here real quick on the board, because this will lead you to the answer. Professor V came out here and he put 7,200 volts for one question, and he put 120 volts for that question, and we figured a 1:60 ratio. I don't remember what the number is. I'm just going to make it up.
It was 5.
Thank you. All right, I'm going to put 5 amps here. We went 5 times 60 equals 300. Now watch this. I'm going to take 7,200 volts. I'm going to change this to 240. I am not going to change the 5 amps. Now I'm 1 to what?
30.
30. How many amps?
5. Oh, 150.
All right. So here's a clue. I raised my voltage. What happened to my amperage?
It changes.
It went down.
Lowers.
I raised my voltage. My amperage did what?
It went.
Okay, okay. What a nice clue right there. Okay. Professor V, I am good to go.
Unless you guys got any other questions, and I encourage you to ask. I had some good questions yesterday come in. I think Ian stayed with me till about 4:30 yesterday afternoon, asking some questions about the quiz. Like Professor Shoemaker said, didn't give him the answers. I asked him questions for the questions for him to work through them. So we kind of coach you in the right direction, but want you to get the correct answer. So any guys you want to, come back on, feel free, we'll be here.
All right, so I don't, everybody hang in here for just a moment, because I got a text from Mark Jones for me to call him. So there might be information for you. Stand by.
Let's see. Hey, Ethan.
Yes, sir.
Hang around after we get done, okay? And I'll tell you how to get to it, okay?
Yes, sir.
Any of you guys that are in the Duke territory are interested in getting on with Duke Energy, Hartsville, Sherrall, Florence, those areas?
Yes. Yes, sir.
I know I got some Hartsville guys in there. And Sherrall, I'm gonna keep checking. I've got a guy from Duke. He's a supervisor over in Florence. I was talking to him last week, and he's gonna, whenever I get back out there to you guys on the field, I'm gonna have him come out and speak to the group, and we'll be able to ask him some questions about the hiring dates. When do we think they're gonna be doing any hiring, or those kinds of things, because I think they're gonna probably open it up in our area before long, because the rest of Duke, I think the Floridas and Ohio, Kentucky, and some of these other places, they're already starting to open up their hiring practices again. And so, and I know there's lots of openings. Matter of fact, when I left, 2 years ago yesterday, when I retired, they haven't filled my job yet. So they've got, I think 2 jobs in Kingstree. They got several in Hartsville, Florence. They all have openings out there. So any of you guys interested, maybe you might have to move, closer to the ops center where, Duke served out of, but I think the closest one to where you're at, if you're in Conway or Ainer or the Myrtle Beach area, Dukes, it would be over in the Marion office over that way. So, I mean,
They serve out in like Wilmington and like Morehead City and stuff too, right?
absolutely. Yes, sir. Yes, sir.
I'm willing to move anywhere as long as it's not here.
Okay. All right. Yeah, Wilmington's a good area. I've worked on many hurricanes back in the 90s up in Wilmington. So
cool.
It's a beautiful area, nice area to work in. It's grown a lot since then, but yeah, good place to work. Excellent benefits. You have to look at the whole package, guys, when you're looking at going to work for a company. And I'll say this about the contractors, the Sumter Utilities, the Pikes. They have actually gotten better over the years with and where they used to didn't offer any benefits before, now they offer insurance and 401k and those kinds of things. And they have all learned to be more competitive. And whenever I retired, I think the linemen with some utilities that contracted out through Duke, they were making very close to what the Duke top linemen were making. Wasn't very, far off from that. So they were making a really good salary as well. So, I mean, I think it's all worth looking into.
Okay. I got a friend who's in Louisiana right now with Sumter Utilities. Sir?
Who is it, Mark?
Blaine Hopkins.
Who's he working with? Sumter, you said?
Yes, sir.
Okay.
I think he worked all through the night last night. Sent me a picture at 7 a.m. So your boy made it to bed.
Nah.
I know a boy that's up there right now, JC Huggins. He's up there right now.
Oh, JC, he went through my class.
I can't remember who he's with.
Sumter.
Is he with Sumter?
I think he.
Yeah, man, Lucas both are with Sumter.
So he's the one that does all my tinting on my windows.
All right, I'm back. Did we lose V?
Yes, we did.